Hello everybody. Let me apologize in advance for the production quality of this video. I know it's going to be bad. I've done a couple of dry runs on it. I'll probably bump the tripod a few times. There will probably be some abrupt jump cuts. I'll just apologize for those. Now that that's out of the way, this video is about a project I've been working on, a 3D printed vertical case for the Atomic Pi single board computer. There are a lot of better videos about what a Atomic Pi is out there on the internet and why you would want one on YouTube. I know there's at least half a dozen videos about it. Particularly there's explainingcomputers.com. That guy does a good video about it. So for more of the technical aspect of it, you might refer to those videos, but I'll give a brief rundown on it. So it looks something like, or it is something like a Raspberry Pi, except that it's a little bit bigger. There is an Atomic Pi. There is a Raspberry Pi 4. So it's a little more than double the size. It's double the size this way, and it's a little bit wider that way. So the difference with this one is that it is an x86 processor rather than an ARM-based processor, so it will run the more common versions of Ubuntu and Lubuntu and all of those x86 Linux operating systems. Raspberry Pi can run a Linux operating system, or it mostly runs Linux operating systems based on Raspbian, but it's a different thing, and there's some software that you might want to run that, you know, more productivity software or whatever, that the standard versions of it don't run on this, and more of that stuff will run on this. So if you're going to use this to set up like a network attached storage or a Plex server or something like that, this thing could run, has a lot more options of operating systems to run than this guy does. Price-wise, it's about the same as this. These are about $40. These are about $35 if you can find them in stock somewhere. They're becoming more easily available. This has 2 gigabytes of RAM. This could have up to 4 gigabytes of RAM, but this has an Intel Atom processor. That's why it's called an Atomic Pi. The secret about these, I guess, is that there was a Kickstarter for a household pet robot thing called Curie, and it failed. And when it failed, the company went bankrupt, and they liquidated their assets. And one of their assets was they had a supply of these little single board or system on a board or something like that, that would be the brains of that robot. But it also works for just running a regular type operating system. But the power was designed to go into this board on this little non-standard power connector. And it runs 5 volts and 12 volts, which is a little bit odd. This runs straight 5 volt. It's a single board computer, but you kind of need this second board, which is a 3D printed copy of one. This in the case is right here. So you need something like that to connect a power supply to, and I'll talk about that a little bit more. So this little breakout board is called the baby breakout board, and there is also a full-size breakout board, which looks something like this. And you take that baby breakout board, of course, and it goes like that. And there's all these jumpers to go to these different various connectors that did robot things on the robot and don't really translate over to conventional plugs for that you'd associate with PCs. One example of this is this is a USB 3. It's the only USB port on the board, but this, it says webcam above it. If we can get it to focus. It says webcam above it, but it's a USB 2.0. So you can get a cable like this for a few bucks. This was about $6, but $4 of that was shipping, and then that'll plug in there. trying to do this through the camera. And then this is just a USB port that has a DuPont connector on the end of it, and I just crimped on some DuPont connectors and taped them together so they don't come unplugged. So that adds a second USB, but it's only USB 2.0. And when we talk about the case more, there'll be some things to say about that. This big breakout board, its power supply in, and see, it breaks it all out. So like these are speakers. I said it was 5 volt and 12 volt. The 12 volt runs an onboard amp on this thing that can output to speakers. Yeah, that's the speaker connectors, and there's these little jumpers to plug into the proprietary, or not proprietary, but more unusual connectors that are on here. So this will run 5 volts and 12 volts, but this one will only run the 5 volts, and then you'll kind of be doing audio through HDMI, and it'll, you know, whatever you hook it up to. So what I use this for, I'm kind of learning Linux. I don't really know a whole lot about it. I've used it quite a bit, but I never really learned more than just, when I have a problem, Google it and copy and paste. So what I use it for is I have it installed in this little case, and it sits behind my TV, and then I have Linux desktop on my TV in my living room, so I can kind of play around with Linux that way. And I can also watch YouTube with the family, or surf Reddit, or look at TripAdvisor when we're going on a trip. We use a PC connected to the TV. So that's the purpose of this. Just a nice little cheap, all in. It's less than $100. So this is, like I say, they're about $40 for the board, and the baby breakout board's about $10, and then you need a power supply to go with that. This is the one I've got here. It's kind of what you'd have with a laptop. It's got a brick, and then something to plug into the board, and then something to plug into the wall. So since it always has to have this kind of lump on the bottom where the baby breakout board goes in, or if it doesn't have that, it at least has this connector down here and some kind of wires coming out of that. I've heard people use some kind of ribbon cable to do that. This thing doesn't sit flat on a table. So I started off on this project, and I made these. It's just a little stand. There's little standoffs that replace the standoffs on your baby breakout board. And if you're not using the baby breakout board, there's some little gray spacers in there. And then this just sits, and it just makes it sit kind of flat. It's not flat now because the baby breakout board. Anyway, that's that. That's where this project started. Just something for it to sit on. So it doesn't, whatever. It doesn't scratch up the table it's sitting on, or... Anyway, that was the point of that. And then this sort of evolved into this piece, which is part of the structure of that case. This is like this here. And the early ones actually had this cross brace, but it's kind of unnecessary, so I took it off in a later revision. So the idea with this case is that it's open. It's got this opening on the top, and it's open on the bottom. So as that heat sink in there heats up, the warm air rises and cool air is pulled in from below. There was a computer back in the early 2000s by a famous company named after a piece of fruit that was a fanless, passively cooled desktop computer that had this cavity through the middle of it, or a channel through the middle of it for all the heat sinks to be in, and the hot air would rise and cool air would get drawn in below. So that was kind of the inspiration for this, but it didn't really go in that direction as much as theirs did. There's some videos came out a year or two ago, and I've been thinking about that computer and how elegant I sort of thought that cooling system was. So I tried to emulate that here a little bit. There is a connector on the board somewhere here that if you look real close, I think it says fan. Is that it? Yeah. So there was apparently at some point some thought into having a automated fan system for this board. I don't know if that's when it was still a robot brain or whatever. They were thinking about accommodations for a fan, but I've been told that there's some resistors or something missing in here. It doesn't actually function, so sort of future-proofing that somebody did at some point that never got finalized, and it just says fan, and it doesn't really work. So that was part of the reason for this passive cooling solution, so that you don't have to try to adapt a fan. And if you've got this in your living room, playing media off of it or something, you may not want that fan running. So it is what it is. So with that all out of the way, next I want to talk about some tips for printing this if you're going to try to print your own from the files on Thingiverse. The files that are on Thingiverse are, they're not this final version. I will update those, probably make a whole separate listing, but there'll be a link down in there to what's up on there at the time of me making this video. But there may be another revision put out. This has some changes to it that change the way a couple of things work, and not everything is completely compatible, but we'll talk about that more as we go through it. So something I should have mentioned, the point of the wood is that, for one, each of these sides, they look like this. That's about 5 hours of printing time. And that's another 5 hours, and then that's about 2 hours of printing time. So if we took this and made yet another side, you're looking at, another 3 or 4 hours per side to print something that takes up this space. So part of it is to cut down the printing time. Part of it is, this is just 1/4 inch thick wood. So anything 1/4 of an inch thick would work to replace this. I sold one of these on Etsy, the same color, and someone put some yellow. The person who bought it put some yellow clear acrylic in the face in place of the wood, and it looks really good. I need to make one of those for myself because it's really nice. Another thing, that gives people who are making this an opportunity to customize something without having to go in and edit meshes or whatever. It also gives you the ability, if you need to mount antennas or a switch or something, you can just drill right through this wood or whatever it does. Whereas if you wanted to try to add a feature over here, you're at least going to be drilling through 3D printed plastic, which doesn't always go so well. It tends to kind of crack out around the hole. So this gives you an opportunity to add something without having to either print it and then modify it, or modify the file, the 3D file, and then print it. It gives you an opportunity for that. So those were the reasons for using the wood face. It's a little country kitschy for my taste, but it was a solution I had on hand. This wood, by the way, that I use is cedar closet paneling. So like if you want to line a closet in cedar, you get these boards and they're like 8 feet long. I did a project, I only needed them 6 feet long, so I had a whole bunch of 2-foot offcuts of this stuff. And in order to fit properly in the groove, if you have some of this on hand, I had to take that tongue off of that one side. I just took a utility knife and just cut it off, and then it's a good fit in there. Originally I tried to accommodate this tongue on the first one, and these had to be wider, and it didn't really hold it in well, so the best solution is just cut it off. Or, like I say, get some other material. Another thing I have experimented with, instead of the wood, I printed just a little 3D printed plastic frame, and I'll put the STL for this up there, and this just has paper in here just to kind of see how it works, and it actually works really well. Once you get it in there, it pinches it tight enough that it holds it in place without like glue or anything. But I didn't intend to do it in paper. Well, maybe some kind of nice tissue paper, some kind of craft paper would be okay. Or I intended to use some textile fabric. My girlfriend drives a old Miata, and we redid the interior door panels in this real nice red brocade fabric. I thought that would look really good, but I guess we didn't keep any of the scraps, so I tried it with paper, and it works as an option for something else to do with the front other than the wood. So finally, some printing tips. I think I said we were going there a few minutes ago, and well, it took us a while to get there. So these all print face down like this. Like I say, these take about 5 hours. That takes about 2 hours. These each take around an hour. This is your USB holder, and this is a little captive nut thing. And then these pieces and the structural piece, forgot to put this guy in here. This is like an hour and a half to 2 hours, and then these are like an hour for the pair of them. So it's a pretty long process to print it all out. And I personally like to print the outside in PETG because I get these nice, somewhat translucent PETGs. Those are just inland green. This one is inland magenta, which if you see it on the roll in the store, it looks like this real nice vivid red color, but then you print it and it's kind of pink. It's really pink. Especially when it gets backlit. Yeah. So, I kind of like it though. I don't know. It's bright. It looks like something that should be called atomic, so. So anyway, I print these face down, these outer shells, the PETG. You know, that's not the kind of surface finish you normally expect out of a 3D printed product. It's very glassy and smooth. It kind of shimmers a little bit. Because it prints face down on glass. PETG does really good printing face down on glass, but there's a few things to be to considerate of as you're doing it. So if you print PETG face down on glass to get that glassy smooth surface, there is a probability greater than 0 that when this cools down, even just naturally cooling without trying to pry it off or anything, in fact, it may be better if you do try to pry it off if you can do it without damaging it. But as it cools down, the glass contracts at a different rate than the plastic contracts, and the plastic will actually tear chunks out of your glass bed. So those are divots in the glass that are a few millimeters deep. And it just, you'll hear it cooling, and then all of a sudden you'll hear it pop, and it pulls out a piece of glass. And the piece of glass that it pulls out is stuck really well to the outside of the plastic, or the downward face of the plastic, and it can ruin your print, and it can mess up a piece of glass. So this is hardware store glass. I got this for $2 at the Do It Best by my house. Actually, it wasn't even $2. It was like $1.60. So. And you know, this is big enough to do 2 faces on, although I would not print 2 faces at a time. I print them one at a time. And you know, it popped on one side, so I was able to print something over here, and then it popped a little bit out there, and then I flipped it over, and then it popped more out over there. I've got a little, I could maybe print another face on this one over here. So that's something to be wary of, and an option to make that happen less. If you do it at 100 degrees, you get a really good first layer, but the chance of popping it out is really high. You do it at 80 degrees, you still get a good first layer if you've got a good low Z offset, but around the corners, it just doesn't, the details don't remain as crisp. You'll get little individual lines. Sometimes you'll get one of these, the extrusion path around the edge of a hole will kind of flake out. So the option here is to raise the bed leveling up a little bit, give yourself another 1/4 millimeter or so of space between the nozzle and the bed on the first layer, and it doesn't stick as well, and it's much less likely to take a chunk out of your bed, but you'll get those visible lines. You can see this whole black one I printed like that at a little bit higher, and you can really hear those. Whereas on this one, it doesn't. It's still got them, but it's not as much. It's not as apparent. I also think the clear just prints better, or the translucent prints better. I also have a blue one that I've done. Nice translucent blue. This one's got a little bit of ghosts in it, but you know, from 5 feet away it looks good if you're not scrutinizing it. Also, none of this stuff needs support I take that back. There are two places that you may need support on this. One is on this structural part. It prints best flat like this. You may want support in there. Those are accommodations for the antennas that came with the developer kit of this, and they look like a fairly common antenna type. So you may want support there if you're going to use those antennas. It's probably not going to fail the print. If you don't use support there, it just won't be a very clean. And this was with support, and it's still not very clean. So, you know, it is what it is. Another place you may need support if you're using there's a accommodation to mount a 2.5-inch drive in it, and this screws to the back of this like so, and kind of completes that circle there. So there's an opportunity for a little bit of support right there, but Cura default support settings work great. If you have never peeled off 3D printed support material, it's almost as good as peeling the plastic layer off a new electronic screen or something. It's just so satisfying the way it comes off. So it's not so bad. There's not a lot of support needed here. There's also a place right here. This is the USB mount, and there's little pegs that slot into little holes on this USB breakout board, and those little pegs could use support, but on the file that's on Thingiverse, there's already a piece of support in there. It's designed in, and it works really well, comes off really clean. Better than letting Cura try to decide how to support it. I just went ahead and designed the support in with a 1-layer gap at each end to make sure it snaps out real easy. And in addition to not needing support, these also don't need infill anywhere. At least these faces don't. PETG is often hampered in its printing quality by infill. When the infill lines cross, a little glob gets on the end of the nozzle, and then it carries it over here, and then you got globs on your outer surface. So I designed these intentionally to make the enclosed area here as small as possible, so this gap you're closing doesn't really need support to make it work. You might do 5 or 6 top layers, and then that's the same way. Like there's no infill in there, but it's nice and strong. Also, everything on these, instead of doing a round curve here, I did a fillet on it so that it doesn't try to make, there I go, bumping the tripod, so that it doesn't have to make that upward curve that gets kind of ugly. So it's a lot easier to print. It doesn't need any support under it or anything like that. So these things take a while to print, but there's no, you don't have to be a good 3D printer to pull this off. The hardest part is getting that good first layer on the clean glass bed. I don't put anything on it. If I print PLA on glass, I put Aquanet hairspray on it, and that really helps with the bed adhesion, but the PETG at 80-degree bed temperature, it doesn't need it. You're also with PETG, if you're running Ender 3, which is where I printed this, or what I printed this on, to get really good PETG prints, you kind of need to go into that 240, which is kind of a gray area. Is it safe to print 240 with a PTFE Bowden tube in the nozzle? It'd be better if you had a all metal hot end. Some of these actually were printed with an all metal hot end. Some of them were printed with my PTFE tube in a well ventilated room, and after just printing a couple of these, I started getting really bad jams, nozzle clogs, and I took it apart, and the end of the Teflon Bowden tube looked like a cigarette butt. It was nasty. I kept it at arm's length and wrapped it up in a wet paper towel and threw it away. Like it was bad. So I would not recommend going over 240 on the nozzle, and you might struggle to get that good of quality. That's going to be the hardest part of it. getting a really good sticky first layer where all the corners stay stuck down while printing at 240 onto an 80-degree bed. You can bump your bed temperature up will help some, or getting a little more Z offset on the first layer, trade off a little bit of the print quality for a little safer printing scenario. So here, watch this. Ooh. No, now it's not going to work, of course. Oh, there it goes. Oh yeah. Oh. Something about that just is so satisfying. So now that we've done that, I've switched over now, abrupt jump cut. So let's put one of these together to see how the assembly process works. Wish me luck. So first, we need to take the, oh yeah, of course. We need to take the baby breakout board off, at least enough to remove these standoffs. Because the round part of these structural parts attaches where the standoffs are. So if you've got your baby breakout board, and actually you'll not be reusing those screws. Of course, I sat down to do this without a flathead or Phillips head screwdriver, and I'm trying to do it through the camera, which doesn't work so well. Oh, this is a bad video. The one I tried to do yesterday really went off the rails, but this one's getting there. Third time's always the charm, I guess they say. Alright, we'll get those out of the way. So this is the jumble of screws that goes with this. The last thing to go on is the top, so I like to take all the screws, dump them out in the top like that, and then if I get to where the top screws on and I've got leftover screws, I've done something wrong. So the first step is, are you going to use a hard drive with this? Because there is an accommodation to mount a hard drive in it, but the only real good way to hook up a hard drive to this board is either through the USB 3, which sticks out through the side of this case. So you'd have a cord be run out from your hard drive, which would be mounted right about here, out to there. Or you can run it off this USB 2. You could have a hub, USB hub here, and you could run from the USB 2 into that, and then one of the hubs out to the hard drive, and then leave the rest of the ports open to use at the bottom of the case. That would be an option for hooking up the hard drive, but your transfer rates are going to be really slow going through this USB 2, so there's just no good way. It wasn't designed from the outset to be this kind of thing, so some things are just not a good way to do it. So if you're going to use a hard drive, we take these hard drive mounts. We take one of these little 6mm long screws and this piece. These don't have to be orange. I just printed them orange so that they would show up as being a different part. And you get these started in. There it goes. So none of the threads are printed on this. They kind of just self-tap in, but it works pretty well. I do, like I said, I like to do the inner structural parts of this in PLA because I find PLA holds threads better than PETG does. I don't know. I keep reading that PETG is stronger than PLA, or I keep seeing people parrot that anyway, and I don't know, maybe in some engineering tensile strength term, maybe it is at ultimate failure strength or something, but I find the PLA, in the way most people would use the word stronger, I find the PLA to be stronger in that it's more rigid. I also, if you know what creep is, the mechanical property creep, or I don't know if it's a mechanical property, mechanical condition called creep, where you tighten a screw down into something and it doesn't turn loose, it just slowly pulls, or if you have something sitting on something and plastic, and over time the plastic it creeps. It's the perfect word for it. It creeps. I think that PETG, at least as it's 3D printed, tends to creep a little worse than PLA, and I think that's related to why the threads kind of strip out of PETG easier. And when 3D printed threads strip out, they don't really like strip out to the point where what they're trying to hold together falls apart. It just goes in and never really, like these, you could see where they like definitely tighten down. But PETG, after you've screwed something in and out a few times, it doesn't it doesn't ever really have that satisfying screw down. So if that ever is a problem on something that's 3D printed, really anything plastic where threads thread into it, you can take a little bit of super glue and like drip it out on a piece of like saran wrap or something, and dip a toothpick into the little puddle of super glue, and then insert it into the hole that you want to restore the threads on. Get it in there really good, and then just let it dry, because the screw, when it goes in, will cut new threads. It's kind of a way to recondition the inside of holes. But like I say, even when they get really bad on 3D printed plastic, they're not stripped out to the point where you're like, it just falls out. It just loses its ability to like really get that satisfying tighten down. So now you're ready to mount your hard drive. You don't necessarily have to do it at this point, but this is probably going to take a third hand here. Too bad I don't have one. Alright, sorry for that abrupt jump cut. I had to go grab some proper screws here. So if the hard drive mounts like that, these pieces up here should meet up with this circle, and the long part should extend down the other end of it, and then all of this mounts on the back of the Atomic Pi, opposite where the connector for the power supply is, or the baby breakout board. The Atomic Pi has 5 mounting screws for some reason. So there are 3 on this side and only 2 over here. So this case, this piece that attaches to it, where the no screw hole is on the board, has a cutout there to make room for some little solder joints that are under there to not be putting pressure on them. So back to trying to do this. It'd be really cool if I knew how to do on the videos where like you fast forward through the boring stuff of assembly and you get those cool like, that'd be cool. Maybe sometime I can do that in the future. Oh, I keep dropping my tools. Alright, so those just go in about like that, and there's 3 of them. We'll jump cut to the rest of them being in. So there it is, the first part of the structure attached to it. So the next thing is to build, I call it the stack, and that's going to be the USB support, and then these legs, and there's a left and a right. They are different. They use these really long screws, so we'll go ahead and start this really long screw through here, kind of like that, and that one about like that. Flip it over. This one goes here. The round part goes to the inside, and the long legs match the the long side of this triangle matched the heat sink. So that goes down on, and now your baby breakout board. And this would be about like that. And now these, this has the captive nuts in it so that you don't have to hold it while you tighten those screws. And the 3D printed side of these, when you put the nuts in, put the long screw through and thread the nut onto it and keep tightening it down until it pulls that nut into the hexagonal hole on the bottom of it. And then this hole on the other side is printed intentionally a little bit small so that you can kind of get it on there. It kind of holds everything. Gravity won't pull the screw back out of it. And then you just start tightening these things down. So these are 30 millimeter long M3 screws. If you can find 25 or 28 millimeter, they may be a more appropriate length. These are a little bit longer than they need to be. So yeah, you just tighten it down until it's all good and snug. So I had put this piece on upside down. The arrows, these triangles, point towards the top of the board on both sides because that's where it catches the wood or whatever your paneling material is. And that little USB port wants to pop out on this PET G. So the next step is to put the sides on. And you could screw the sides to these legs first, but then that nut there, that nut we just did, is really hard to get into place. So I always start with the little ones. These are M4 by 6 millimeter screws. When I originally designed this, it didn't have these structural pieces. And it was cleaner, and it was fewer parts to print, and it was a lot fewer screws. But it was really hard to get this screw into place. You needed one of these ball end, focus. One of these ball end things, hex keys, to be able to get down in there. So I added this as a way to do it, and another thing that I wanted to do on this part of the design is to make the plugs around the perimeter of the board, the sockets, all of these, be able to be reached without completely dismantling the case. So once you when you take it apart, once you get the lid off and undo these two screws on each side, this can swing out like this, so then you can reach those if you need to plug something in or whatever, without stripping it all the way down to, you know, the bare board. Since it's quite a project to put one of these together. I think it's kind of a fun little thing to do. Almost like putting a Lego set together. So this thing can stand up on these feet even without one of the sides on, but once you get one of the sides on, it's really sturdy. So the ones that I made without these would also had a lot less rigidity in this direction. And on them, I had one here a minute ago. On the original sides, this spacer was just printed as part of this side, or the sides, and like I say, it was really hard to get the screw in there started, and it wasn't as strong that way, and the side that I have from when I did that actually has cracks in it around where that that thing would be printed on. One of them had just completely cracked off, so I reinforced it, and then the reinforced one just cracked this side. These sides are only 1 millimeter thick. On the latest iteration, there is a 2 millimeter thick collar around each of these, the holes that go to the ports. Another thing about this is that when it's all put together, this structure stands about 1 millimeter from the side of this board. So you could put a ribbon cable through there. The antenna, since the antenna connects here, would have to go around the side of the board to get to these antenna slots in the back. So I left basically 1 millimeter of gap between the board. But you don't want to pinch your antenna between this structural piece, the antenna wire, between the structural piece and the side, because that does fit straight up. But you can go around this board and in through that slot right there to get your antenna up to there. So these screws up here are 10 or 12 millimeters long. These may be longer than that. I may have been out of 10 millimeter long screws when I was doing these. So all of these screws, if you go to a hardware store and buy them, like I say, my hardware store do it best. They stock all of these screws, but if you get them from them, they are, or any hardware store, you're looking at 30 cents a piece for 20 screws. So you're looking at $7 worth of screws basically, because 30 cents a piece on some of the small ones, and some of the bigger ones are like 47 cents a piece. Which is ridiculous. Menards, I saw, had these screws individually wrapped, and they were like 60 cents a piece. It'd be like $12 or something to put this together. So you can get on Amazon, which I hate, but you can get Amazon these screws in boxes of 100 for less than $10. So there you're paying like 8 cents a screw. So if you get them at a hardware store, they're really giving you the screw. So the side goes on something like that. The other side does the same. There's another screw hole here. I haven't started yet. So we'll jump cut to the other side being on. So there's the other side on. There's the hard drive in the back. So I bought this connector to connect to the hard drive, and it fits in there except for this part. On Thingiverse, there's a different version of this that has a hole in the middle, and this is spaced out a little wider. And this will go on right there. But then, like I say, you've got this connected to your hard drive under there, and like, how do you connect it back into the board there? If this wire was a lot shorter, you could roll it up and maybe just connect it to a USB. Good God. A USB hub. You could put a USB hub in place of this one connector, and then have multiple USB 2.0s and have your hard drive connected without a wire running outside like this ridiculously. But like I say, you'll only have USB 2.0 speeds on that drive. So something, switching topics, something that I have started to understand when working on projects like this, nobody's tolerances are perfect on a 3D printer, especially not a $200 Ender 3, which is what I've been using on this. So when you work on a project like this and a lot of pieces go together, sometimes you get to a piece where all of the tolerances that you've sort of been fudging the rest of the way all get together, and they make something like not work exactly right. And I'm not saying that this doesn't work exactly right, but you'll witness this in action. So the backs go on, and these kind of pop into place. Tolerance isn't perfect on them, so you kind of got to wiggle it a little bit to get them in place. You get them in place, and then you put the lid on, and the lid goes something like that. And then when you start these last screws, you know, tolerances, everything's kind of adding up, that these screws are just a little bit off from each other, so you really kind of got to squeeze kind of hard right there to get these screws started. And sometimes they go in, they look like they're going in a little bit crooked like that, but that's as good as you're going to get it, and as you tighten it, it'll straighten up. And it's not like screwing into metal where if you cross thread something, you screw it up completely. It's more forgiving, especially this PETG, because it'll just creep and it'll take whatever shape it's going to eventually take. That one across the room. Yeah, we got that one going. And there they all are. So on Thingiverse, there are a few different options for finishing the top. There's also another option which I'll show in a minute to put a liner inside of this. I also should have mentioned before this wood goes in, before the lid goes on, if you're connecting something to USB in there to that port, you want to do it before you tighten this side down so that you can do it while that side is flipped open. So, so there it is, all put together. It's not bad looking. You've got access to your USB port and the SD card reader. One of the things about this board is it has 16 gigabytes of onboard storage, but you can also use SD card reader, and you could have the hard drive with whatever operating system plugged into this, and then you could have pretty good read-write speeds and boot up and whatnot through the USB 2 port, but that would require external cable running up, which looks a little clumsy, but it is an option. So on Thingiverse, there's some different finisher panels. This one is not up there yet, but it will be. It just kind of snaps down in there. To keep dust from getting down in there. There's one that's a honeycomb pattern. There's one that looks like kind of a car grill pattern. And that would be something that would be real easy for the end user to sort of customize however they want. This just has these little protrusions that fit along those grooves, and kind of just the layer lines meshing hold it in place. And it kind of, no, fail. So anyway, that's the little finisher panels on top. So these holes on the top accommodate the antennas that came with the developer kit. They look like that. They're apparently not really all as common as I thought they were. I kind of looked them up online, like, oh yeah, you can find those, but like that's kind of like a industry standard or something, that little thing. So it kind of fits in here like this. I broke one of these in the process of prototyping it all, so it kind of fits in there on the top. And that was the point of those holes. It also kind of looks like a little face and some teeth in there. I don't know. Anyway, that's about as far as I got with design aesthetic on it. The pink one, this version is newer than the one that's on Thingiverse. This one is different than this one in that this one has countersunk screw holes. I'll probably put that on Thingiverse, but this thing has 7 screws on the side here. Yeah, 7 screws on the side. This reduces the screw count by 1, spacing these closer together and kind of redesigning the bottom of it. That's different than what's on the Thingiverse one, and this is the latest one that I did. I'll probably keep this, and all it did was added this. There's a bevel here as well as there. On this one there's a bevel here, and then the whole top is flat. But I did that as kind of a stylistic thing, just experimenting with it, and there was a few little problems with it around the top of this because it actually lowered the top of this. Anyway, I had to cut it by hand, so I'll probably be keeping this pink case. But the blue one and the black one and the green one we were looking at earlier, And then I have a white one that's a really old one. Have them listed on Etsy. I'm not making a lot of money on them. I kind of put this one up there, having all of the various features to it to see would somebody pay enough to make it worth my while to make a bunch of these. But it's been sitting up there for a couple of weeks and nobody's shown any interest, so I probably shouldn't even bother making this video, but I am. So anyway, if you want one of these ones that you see here, well, probably not the pink one, but this one or the green one, which I put away, or I have a white one that's up there listed that's PLA. The white one is the old style without these down here, so you need one of these kind of ball end screws. Anyway, the money from them, like I say, the screws on these were costing me $7 to $10. It's $5 or $6 worth of plastic in there, and I have on order these plugs, which I'll include with these kits if these plugs ever come in, and it's got a USB port that's included. So I'm not really making any money. It'd just be nice to get some of the money I devoted to these various iterations I've done experimenting with stuff, to get some of that money back out of it to buy PLA for my next project, which is something Raspberry Pi related that I've been working on. So anyway, if you like what you see, the STLs are free on Thingiverse, or like I say, you can buy them at my Etsy shop. Thanks for watching. If you have any questions, leave them in the comments, and if this video is at all presentable, maybe the next video I do, I'll talk about this thing, which is Raspberry Pi 7-inch screen, little game console that I made so I can sit here and play old school games while I watch TV with my girlfriend and my dog over there, Rusty. He's been under the weather. Say hi to Rusty. So thanks for watching, and if I do this again, this is what it'll be. I'll see you next time.